All right, so example 2, 5.6. This is video number 2, part 2 of 5.6 in Foundations Math 30. And we're going to do one more example here before we talk about the key review points. So example 2 says this. It's solving a problem that involves independent events using a graphic organizer. So a graphic organizer would be just a way to display your information. So we did outcome tables, we did tree diagrams and that sort of thing. So we're going to use one of those for this question. All 1,000 tickets for a charity raffle have been sold and placed in a drum. There will be 2 draws. The first draw will be for the grand prize and the second draw will be for the consolation prize. After each draw, the winning ticket will be returned to the drum so that it might be drawn again. So return to the drum makes them independent events, right? Because everything resets, the drawing of the first prize doesn't affect what's available for the second. So these are independent, okay? Max has bought 5 tickets. Determine the probability to 0.1% that he will win at least one prize. Okay. Now, I did say that there's involving a graphic organizer, tree diagram, Venn diagram, that sort of thing. I also want to show you how to do it using the principle of inclusion and exclusion. So that's honestly, that all of that is probably about the same as far as how easy this is. But I really like the principle of inclusion and exclusion for this question. But first, let's understand the question. So there's 2 prizes, okay? So there's a grand prize and a consolation prize, right? So let's say we have in a tree, let's do a tree diagram of this, okay, a tree. So we have the probability of the grand prize, P of G. And here's the probability of not getting the grand prize, P of G prime, okay? So what is that probability? Well, there's 1,000 tickets, and how many tickets does Max have? 5. So there's 5 of his tickets in amongst the 1,000 tickets. So the probability that he could win the grand prize would be 5 out of 1,000. Okay, does everyone see that? I apologize, that's so small. I should try and zoom into that a little bit, sorry. Just to fit everything on the page. Okay, let me try that. Okay, so 5 out of 1,000. Now, the probability of not, do we need to fill this out? Yeah, we could. That would be a pretty high percentage, and that would be what? 995 out of 1,000, I guess? Right? That's the probability of him not winning the grand prize. Okay, well, that's draw 1. That's draw 1. Draw 2, okay, if he doesn't win the grand prize, which is most likely, right, he still has a chance for the second one. So the second, the tickets are all being replaced, so he has 2 options there. This is the probability of, let's say, what's the consolation? So let's say probability of winning the consolation is, okay, now how do we do this probability? Well, there's only one prize, and so it's 1 ticket wins it. He has 5 tickets in the game still, and there's still 1,000 because the tickets were all replaced. So does it make sense that we have probability of winning the consolation is the same, 5 out of 1,000? Is that okay? All right, you get that? So all the tickets are being replaced. There's only 1 winning ticket. He has 5 chances of getting that 1 winning prize out of the 1,000 that are there. And so the probability of no consolation over here, right, is, and you can put the little prime symbol outside or inside, I suppose. I think it probably should be inside, to tell you the truth, if I was doing that completely correctly. So let me just change that for you. It doesn't really, oops, did it again. Probability of not winning the grand prize, not winning the consolation. Okay, and this is going to be, again, 995 out of 1,000. Okay? So up here, if he wins the grand prize, boy, that would be amazing. But he also has the chance of winning the consolation. So we've got our same percentages here. 5 out of 1,000. Be consistent with my colors there. So 5 out of 1,000. And the probability of not winning would also be C prime would also be 5 out of 1,000. 995, sorry, 995 out of 1,000. Okay, so now that I've got that all in there, these are the outcomes, right? These are the outcomes. And this outcome right here is going to be the probability of him winning the grand prize and the probability of him winning the consolation prize. Okay, so that's winning both, right? This one's going to be the probability of him what? Winning the grand prize and not winning the consolation. All right? So this is both. This is one of them. Okay, as we move on, this one down here is probability of not grand prize and the consolation. So that's, again, that's one of them. And we have the probability of not grand prize and not consolation. Okay, so that's neither. And that's probably going to be the biggest percentage, right? 5 out of 1,000 chance twice. So yeah, it's going to be the highest percentage is going to be this one. Not winning anything, unfortunately. Too bad. So what do we got? So for this one, winning both, we've got 5 out of 1,000 and 5 out of 1,000. Do we add or multiply those? Multiply is correct. So what is that? That's going to be 5 times 5 is 25. 1,000 times 1,000 is 1,000,000. Something like that. No, 100,000, sorry. Wait. 1, 2, 3, 1, 2, 3, 1, 2, 1, 3, 1 million. Okay. Multiply those together. Okay. So what about this one? This is going to be 5 times, okay. Well, let's just pause here for a second. Do we need to fill out this whole tree? Well, let's just think about our question. If this is you doing this, which I strongly encourage you to do a graphic organizer, but I will show you the math, just the principle of inclusion and exclusion right after this. But if you do this, you don't have to fill out the whole chart all the time, okay? What's the question actually asking? Determine the probability to 0.1% that he will win at least one prize. Ooh, remember this wording, at least one. So that means, what's the probability that he's going to win one of them or both? Right? Everything but neither. So we need to figure out this one, we need to figure out this probability, and we need to figure out this probability. But we don't need to figure out the neither. So let's move here now to, let's move to decimals here. So it's going to be a little bit easier if we can work this in decimals, okay? So what I mean is, instead of dealing with the fractions, let's just go straight to decimals. So 5 divided by 1,000 is this decimal, okay? And if we take that decimal times itself, that's going to be 2.5 times 10 to the negative 5, okay? So I'm going to change this to a very small number. 1, 2, 3, 4, 2, 5. That's 2.5 times 10 to the negative 5. That's a very, very small percentage he's going to win both. That's not the answer, though. It's at least one. So one or both. So it's both or this one or this one, right? So what do we got here now? Let's go back to the calculator. I've got 5 times 995. 5 times 995 divided by, all right, 1,000 times 1,000, which we figured already was 1,000,000. So what's that? 0.004975. 0.004975. Okay. And then this one here too, well, that's going to be the same, I think, isn't it? Because we have the same numbers. So does it make sense? Does it make sense to you guys that we should add all these up, or is there something that we're missing? Should we just add all these up, both, or 1, or 2? What do you guys think? Let's talk it out. Okay, let's make a Venn diagram to see what we're doing here. So this is grand prize right here. This is consolation prize right here. We could have somebody winning both, obviously. So G and C is here, right? G but not C G but not C is this. That's G without C. Okay. G and everything that's not C. This one is C and everything that's not G. So that's this one, C, except what is G. So are these three overlapping, or are they three separate? What do you think? Okay, you think we're going to add them all because they don't seem to be overlapping, they seem to be separate. Okay, let me just show you the algebra part of it, okay? Let me just show you the algebra part of it. For example, the principle of inclusion and exclusion, okay? This is going to be, this is a good part where you just do the math part, and the organizer is great, but let's just see what the other side looks like. So what we're doing, we're looking for the probability of G or C. So we know that we add the probability of G plus the probability of C minus the probability of G and C. Do you remember that from last chapter? I think it was chapter 4 we did that. Okay. So what's the probability of the grand prize? Well, that's this 5 out of 1,000. That's 5 out of 1,000. What's the probability of the consolation prize? Well, that's also 5 out of 1,000. Now, if we simply do that, we are taking into account, we are double counting the middle. We're doing all of this and then all of this. So we're double counting the middle. We have to take the middle away, the overlap. So what is that? That's this number right here. Okay? So 0.0000025. So when we do this on our calculator, what we get is we get this. 0.00997 5. Okay? That's what we get. So what do we get when we add these together? Let's see. Because this is correct. This is our probability right here as a decimal. So let's see. We've got this number right here. Okay, we're going to do that times 2. And we're also going to add 0.0000025. Look at that. So yes, the answer to that previous question was over here. Once we do the tree diagram, these are all separate. We just add them up. And you get this number right here. Now, as a percent, that is 0.9975%. They ask you to round to the nearest percent, so that's 1.0%. So there's a probability, a total probability that you will win at least one prize of rounded off to 1%. Okay? There's a probability of winning both. There's the probability of just winning the grand or just winning the consolation. And all of it would be all that added up. Okay, 2 different ways of seeing that. Anybody have any questions? No? We're all awake? We're awake? Hi. Good. I'm just really meditating on this stuff, eh? Okay. All right. You all right now? Okay. Anybody else dozing off on me? No? All right, we good? No questions? Tree diagram. Principle of inclusion, exclusion. Even the Venn diagram there. So you have all the different tools here. Okay, let's do summary of this section. So the key idea is if the probability of event B does not depend on the probability of event A occurring, then these events are called independent events. Okay? If you want the probability of 2 independent events, you simply multiply the probabilities of each individual one. Okay? No problem. That's pretty basic, kind of like what we've been doing before. A tree diagram is useful for these problems. Also, Venn diagram, the principle of inclusion, exclusion, as you just saw in that last example. Okay, drawing an item and then drawing another item after replacing results in a pair of independent events. We talked about that earlier in the lesson, I believe, right here, just before the end of last day. So with replacement is independent. Without replacement would be dependent, which that's what going to be the focus of our next lesson here. In dependent events, okay? All right.